The Caspian Sea is known to be the largest lake on Earth by both area and volume. It is still called a sea because its water is salty. It is a warm sea, good for recreation. In modern times, the Caspian Sea has become known for its oil exploration, and sea oil rigs are a common sight everywhere along the shoreline. Oil extraction from sea and land has its price tag in the way of environmental pollution. There are many sound scientific reasons to study the Caspian Sea, ranging from welfare of marine resources to climate change. A seagoing research vessel made a 2-week summer cruise along the coastal waters of the Caspian Sea to study another type of pollution, radioactive contamination. Radiation in seawater sounds frightening enough for laymen, but from a scientific point of view, one has to remember two things. One is that seawater contains natural radioactive substances that have always been there. Another, and the point of current study, is to find out what amount of man-made radioactive substances have got into the sea. For all we know, there are two major contributing factors to man-made radioactivity in the Caspian Sea: atmospheric bomb tests in the 50s and the Chernobyl accident. Other potential sources of radioactivity, such as nuclear activities of the 5 nations that border the sea, will be carefully scrutinized in the current study. The Caspian Sea is a landlocked body of water, and everything that goes in it hardly leaves its waters, as there are no connecting waterways to high seas. Studies of its radioactivity isn't a novelty here, but the studies were disrupted with the dissolution of the Soviet Union. The IAEA organized a study there in the mid-90s to help understand disturbing changes in the water level. A decade later, the government of Azerbaijan asked the IAEA, through its Technical Cooperation Department, to make a new study, this time to understand levels, sources and paths of radionuclides. The tiny quantities of cesium, strontium and plutonium in seawater react differently. Some are easily dissolved, remaining suspended in water, and some finally go to the bottom. The ship has an array of sampling instruments to pick up these tiny quantities from both water and sediment. Later on, in highly specialized laboratories, scientists will analyze the samples with techniques allowing to see even minute traces of radioactivity. This instrument, for instance, checks the salinity and temperature of seawater, acting like a kind of detective, seeking the depths at which sampling should be optimally carried out. This structure that resembles a deep water probe is indeed a probe that is sunk to the bottom of the sea. It grabs a column of bottom sediment, which is a collection of heavier particles that have been deposited in the sea bottom over many years. Detecting radioactive particles in the sea is a pretty common task for radiation science, but the real find will be to investigate how much, where, and where from. This is the scientific target of the Caspian Sea cruise.